So with any problem that has a plus in the middle, we can only add them if we've got a common denominator, or if we can reduce it beforehand. And it's always, I think, a safe bet to factor your fraction that looks to be the common denominator, but it's better to get a better picture of it. So your factors here are 4x and 2x plus 1. Now you can't cancel that and call it a -1 or something like that. You just got to kind of deal with it as it is, and what you can see here now that you factor that is you're missing a 2x plus 1. So you do that to the top and the bottom, 2x plus 1. Okay, and a very common thing that I see people do, first of all, before they even did that, some people will try and cancel those 4x's. Okay, don't do that. This is not a something over something situation. You're trying to, and you need to think about this when you start going. That's a plus. You need these things to match on the bottom before you can do anything right. Now that you have this 2x plus 1 top and bottom, your common denominator is 4x times 2x plus 1. But you got to pay close attention to your numerator now. Your numerator, big picture, consists of that numerator plus that new numerator. Okay? So 2x minus 1 plus this 2x plus 1. Okay, now don't get carried away with canceling, because it's not like they just cancel each other out because one's a plus, one's a minus. The ones do cancel each other out. A plus 1 and a minus 1 go away, but this becomes a 4x, which conveniently enough matches something on the bottom here. Now that is the entire numerator now that I add these two 2x's together. You cancel that with this, and you're left with a 1 over 2x plus 1. All right. You come over and look at this thing here, and I don't know if I didn't even, you couldn't see that before. If you couldn't see that on the previous video, sorry about that. I just realized I was really zoomed in here. Okay, so we're going to factor. Those are perfect squares, so we can factor those to conjugates. And so when I factor those to conjugates, I'm going to end up with a 2x plus 1 and a 2x minus 1. Well, and I'll get to the bottom in a second. That's a divided by a fraction. If I say times and I move things around, that goes down here, x cubed. And this, when I move it up, I can take out an x cubed, and I'm left with an x plus 3. Now let me show you something here, folks. This is a factor cancel fest, right? If I see stuff on top that looks like it could be things that go into here, why don't we just use that information to set up these factors? Now, yeah, you can factor, and I can factor all day long here and show you examples. But let's try something here. I know x plus 3 could potentially go into this equation because the 3 goes into this -3, and that x goes into 2x squared. So this is no guarantee that it's going to work, but I kind of have an idea that some of these things are going to cancel. Okay? Now, if I've got an x plus 3 here, what's the possible fraction? If we're looking at the other one, that's a positive 3. I need a -1 here to be able to multiply to get that. And then if I've got the -1, then I've got a 2x minus 1. Again, no guarantee until I take a closer look. Does that times that give me this? Yes, it does. Does the outer term and the inner term, which is a 6x minus 1x, give me that? Yes, it does. And finally, the last term, -1 and positive 3, gives me that. Okay, don't always feel like you have to factor if you've got the means to kind of, to kind of conjure these things up without actually having to factor. So there's a little trick you can utilize. Reduce those, reduce these as is, reduce that, and you're left with 2x plus 1.